mathematicians, welcome back to another video. We are going to talk about linear functions yet again, and if you want to know more about linear functions, you can find a whole playlist down there at the top of the description as well as in the info box. And now we are going to dive right in. Remember, we have talked about the identity function before. The identity function is a proportional function that went through 0, 0. I mean, it's a proportional function, so by definition that holds true. And it went through 1, 1, and -1, -1, 2, 2, etc. Meaning we could get ourselves a line that looks like this. Good old linear function that goes up 45 degrees. Now, what we are going to do today is, before we get to the general linear functions, okay, of the form ax plus b, we would like to move our identity function around on the y-axis a bit. Meaning we are going to move it up and down on the y-axis. And we are going to see how our y-intercept is connected to the movement of our function up and down. What is the y-intercept exactly? So first things first, the functions we are going to take a look at today are of the form x plus b, where b is our y-intercept. Okay, it's just a notation-wise thing. It's called the y-intercept. And now we are going to take ourselves a little example out of infinitely many examples and see how our y-intercept is going to be in relation to us moving the function up and down. So let's say we are going to move the center here, 0, 0, up by 2 units. Let's say our function thus goes through 0, 2. Meaning, we also have to move this point upwards by 2 units. So from 1, 1 it goes to 1, 3 overall. And let's move this point up by 2 units. So from -1, -1 it goes to -1 and 1. Now we can connect dots yet again, connect points. And we are going to get something like this that we are going to call g. And once again, since our function is just the identity function, our slope is exactly 1. Hence, no sign in front of the x right here, or no real number in front of the x, meaning overall our g of x is yet again of the form x plus b, with the only difference being that we have moved it up and down. And now we are going to find out what b actually is and how it connects to us moving this up and down. Okay, we have a function which has one unknown here, one unknown parameter, which is b. Meaning, we can solve a linear equation uniquely for b if we were to plug in one point exactly. And we're going to do this kind of smart, because you know, if we were to get rid of our x, for example, make it 0, then we would have 0 plus b, and this is exactly b, because if you have b apples and you don't place any other apple next to b, then you just have b apples left, alright? I mean, we are going to look where our x is exactly 0 on g, and then we are going to plug this very point into there. And I mean, it's kind of obvious, because exactly at the y-intercept, where we intersect our y-axis, we are going to have x being equal to 0. Meaning this right here is 0, and okay, we have moved it 2 units upwards, so 0 and 2. And now we are going to plug this boy into here and see what we are going to get. If we were to plug 0 into our g evaluate at 0, well, this is exactly 2, this is our y value that we are going to get out on the other side. And this is, okay, 0 into x, so we are going to get 0 plus, okay, and b is our unknown parameter. So we have a very difficult equation to solve, which is actually already solved, because 0 plus b is nothing but b, meaning overall we know that b is hence nothing but 2. Okay, we found out what b is, so what to do with this? Well, obviously plug it into here. I mean, we can substitute it into here, leaving us with a function for g of x being exactly equal to x plus 2. Okay, hear me out. We have moved our identity function 2 units upwards, and now suddenly we have that g of x is x plus 2. 2 units upwards in positive y direction gives us plus 2 as the y-intercept. Now one could say, okay, hold up, meaning if we have a function h of x, f of x, whatsoever of the form x plus b, this just means that if we have b units moved upwards, okay, then it just looks like this. So let's say we are going to move it 3 units upwards, then we are going to have plus b. If we were to move our identity function down, like b units downwards, then we are going to have negative b in some way. This is what one could propose. I mean, we moved it 2 units upwards, we have plus 2. We can move it 3 units down, and probably we are going to get negative 3 as being our y-intercept. Is this true? Let us try it out. We are going to move it 3 units down. Okay, so 1, 1 becomes 1 and negative 2, and now we can connect dots yet again. Once again, we are going to eliminate our x that we are having here after putting a point in smartly, meaning we are going to have 0 and negative 3. Okay, if we were to put this into our h of x, we are going to have h of 0 being exactly negative 3, just evaluating it at this point. And if we were to plug in 0 into h of x, we are going to get 0 plus b, which is nothing but b yet again. Meaning b is negative 3, and our claim basically holds true. We now have that h of x is hence nothing but x minus 3. Moving it 3 units downwards means, at the graph, moving it 3 units downwards, means that we are going to have negative 3 as being our y-intercept. Moving it 100 units upwards, we are going to have plus 100 as the y-intercept, and so on. And this fact with moving it up and down is going to hold true even for general linear functions that we are going to get. And this is what we are going to basically cover next time. I thank you guys for watching. If you did enjoy this video, please like, subscribe, recommend channel, like everyone, support channel, be more, support channel, also check out the main channel whatsoever, and until the next video I wish you guys a flammable day. Ciao!